Good morning and welcome once again to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today I want us to discuss Pure Mathematics 1 example 11 on page 164. And we are going to use the knowledge of the gradient of the normal. And this is video number 14 in this topic. And in the question, we are told to find the equation of the normal to the curve with equation, the curve itself with equation y is equals to 8 minus 3 root x at the point where x is equals to 4. And we remember that we must have understood the gradient of the normal is perpendicular to the gradient of the tangent. And every time we mention the tangent, please know we also mention the curve, because the gradient of the curve is equal to the gradient of the tangent at the point of contact. So the very first step of this question is to first of all find the gradient of the curve at when x is equal to 4. But even before then, we ought to have gotten the value of y. But let's start with dy dx, which is before we even go to the dy dx, we need to clean up a little bit of this equation. Let's talk about y is equals to 8 minus 3x power a half. And what this gives us is now dy dx, which is 8 is a constant, it dies, negative 3 over 2 x negative a half. That is the dy dx. And what is this? What is the gradient, the numerical gradient when x is equals to 4? Now we talk about dy dx is equals to minus 3 over 2 multiplied by 4 raised to power minus a half, which is minus 3 over 2 times 1 over square root of 4, which is 2. When it goes to the denominator, of course, this sign changes to positive, and we are getting our gradient minus 3 over 4. That is the gradient. If that is the gradient, what is the gradient of the tangent times the gradient of the normal is supposed to give us negative 1. And this is the gradient of the tangent, and it is, as by extension, the gradient of the curve. This one is the gradient of tangent and the curve, because remember, the gradient of the tangent is equal to the gradient of the curve at the point of contact. So the gradient of the tangent is equal times the gradient of the normal should give us negative 1. So minus 3 over 4 times the gradient of the normal should give us negative 1. If we multiply both sides by negative 4 over 3, so minus 3 over 4 times minus 4 over 3 is equals to negative 1 times minus 4 over 3. We have multiplied both sides by this constant so that we can clear out there is already the gradient of the normal there. So the gradient of the normal happens to be, the gradient of the normal happens to be 4 over 3. The product is supposed to give us negative 1. So the normal now, the gradient of the normal is this one, but of course the normal passes through the point xy and the point 4 something. We don't know. So we need to exactly understand when the normal passes through the point 4, what is the other value of y? It also happens to pass through a general point xy. But we need to know the numerical y coordinates when x is equals to 4. And we just go back to the curve because it's the curve. The normal and the curve are touching or intersecting when x is equal to 4. And at the point of intersection, the both normal and the curve give the same value of x coordinate and the same value of y coordinate because they pass there. So when x is equals to 4, y becomes 8 minus 3, 4 raised to power half. And of course, this is 8 minus 3 times 2, 3 times 2, 8 minus 6, which is 2. So the normal as well as the tangent is passing through the point 4, 2. The value of y itself is 2 at that particular point. What does that mean? That the change in y over the change in x should give us the gradient of the normal because normal is a straight line. Think about normal now. Normal is a straight line because it is. We know very well that y minus 2 change in y all over x minus 4 should give us 4 over 3. And this is just cross multiplication. 3y minus 6 is equals to 4x minus 16. 4x minus 16. And the equation happens to be 3y is equals to 4x minus 10. In other words, we can just have it like 3y minus 4x plus 10 is equals to 0. And that is now the equation of the normal. We have to leave it that way. Two important points. One, we had to get the gradient of the curve at that particular point of contact. Once we get the gradient of the curve, we have to remember the gradient of the curve times the gradient of the normal should give us -1. Another very important point is that we had to get the value of y when x is equal to 4 because without y we cannot get the value of, or rather the equation of the normal. Okay,